If you are using Märklin, and at some point you will envy DC users for the huge variety of turnouts and crossing types which are available. This tutorial will show you how to convert and equip and wire DC turnouts to use on Märklin layouts. Märklin rolling stock, especially older models, have huge wheel flanges, so you have to take that in account. If you are using K tracks, the best is to use code 100 DC tracks, as they don't require any special joiners or filing. With C tracks you can use code 83, but unless you are using only newer rolling stocks from 2000 or upwards, the flanges will hit the ironmongery, thus rolling badly. So you will have to try out before buying a large number of switches. Code 75 tracks are too low. In this case we choose to work with Pico code 100 to curve turnouts. First, the turnouts need to be modified. When using servo motors you have first to remove the holding spring. Remove all connections which are used for the frog polarization. When using the turnout in a Märklin system we have to polarize the switch blade so that the center pickup doesn't short circuit when driving over it. Check with a multimeter that everything has been removed and the switch blade is not connected to the frog anymore. Solder 2 cables to each track in the switch blade. When you are done, mark the position of the turnout on your layout. Due to the huge amount of cabling, it is the easiest if you can take that part out of the layout, so you don't have to work head over. Cut the flag tracks between the turnout. When everything fits, solder all joiners to the track so they won't move in the future. Now we will drill some holes. Mark the position where the servo wire will come out. Then mark the position where the blade feeder wire are. Make a 6 or 8 meter hole for the servo and 3 mm for the feeder. Pull the wire and check that everything is in place. Now we can start installing the third rail. I will use the Pico studded copper band. There are similar products also from other companies. There are two types of band, the one with lower studs for regular track and the one with higher studs for switches. The band is glued with super glue to the underside of the sleepers. If necessary, it can be adjusted during a couple of seconds or removed with force. The band should be laid in the middle between both tracks. In a turnout it will need to be moved a little bit off center right before the inside tracks. The last stud should not be too close to the inner tracks, otherwise it will short circuit. Keep it 2 to 3 mm away. The track will be polarized, so it won't be an issue if the pickup isn't lifted up enough. This is especially important when you use extreme lean and long switches. Now it's time to test. I used a car with a lamp inside. Now slowly move the car over the tracks. If you feel any resistance, try to bend and move the studs a little bit. Repeat until the car rolls properly. When you're happy, solder the loose ends and attach some feeder wires. Use the Dremel to cut the tracks right before the frog, otherwise it will short circuit when you roll over. For the moment we have to manually polarize the switch. The inner track, the one you roll on, is connected to ground, usually the brown wire. And the other feeder is connected to plus, usually the red wire. Now move the car and check that the light is always on and there are no shorts. This procedure is very crucial. If it's not done correctly, the train will get stuck or worse, create shorts every time they run past the switch. Moving stuff by a tenth of a millimeter usually solves the problems. You can also drive a locomotive now. Use one which gets often stuck. When you are finished, cover the underside with black electronic tape. When everything runs perfectly, it's time to mount the tracks on the board. Drill additional holes for all the feeders. Pull all feeders through and then fix the tracks the usual way. The track bag should be soft enough as the tracks are not flat anymore. To control the turnouts, I'm using a servo motor with the ESU switch pilot servo with extension module. Other motors and feeder solutions are possible. For example, frog juicer could be used instead of the switch pilot extension. First, I mount the servo the same way as I do for my other switches. Then I program the decoder that the servo moves correctly. It is important in my case that the switch blade doesn't touch any track midway when I change the polarization of the tracks. For the connection of the polarization feeder wire, I use position A for turn and position B for straight. Connect both wires to the COM terminal on E and B of the corresponding servo. Then put both feeder wires according to the diagram. In case you do it wrong, debug it the following way. Remove both plugs. Put the A1 in and test that A works properly. If not, exchange port 1 and 2. Remove A and connect B. Repeat the procedure for B. Put back in. If it doesn't work, check again. Now do a final test by running a locomotive over the turnouts. Integrate that module back to your layout. Then mount the remaining tracks. Twig tracks can be joined using the Pecco code 100 joiners. Run your trains. In case one gets stuck, try to adjust the studs. So that's it. This solution is unfortunately quite time consuming. It took me around 6 hours just for the switches. If you do it more often, it might go a little bit quicker. If you liked this video, please give it a like and subscribe to my channel.